Hi guys, today we want to take a look at noble gas abbreviations as well as configurations for ions, which I did talk about in class. So it's just some notes for that. And then we're also going to talk about valence electrons. So in your notes, we're going to, for now, skip the little part about how to write orbital notations. We will do that on Thursday and Friday. And so just go to the part that says electron configurations, writing shorthand electron configurations, okay? All right, so that's kind of where we're at. Now, remember, the periodic table is our friend. So on your chemistry cruncher periodic table, you can actually label parts of it because you'll remember the S block are the first two columns on the periodic table. The P block are those last, we have the P's and the D's, right? And so we can fill our electrons this way. If each box is an electron, you can read it from left to right. So if you were doing the electron configuration of nitrogen, we would do 1s2, 2s2, and then 2p3, if that makes sense, right? So 1s2, 2s2, 2p3. All right, let's say we were doing chlorine. Okay, whoops, sorry. Chlorine, 1s2, 2s2, 2p6, 3s2, and then 3p, 1, 2, 3, 4, 5, 3p5, right? Okay. Super sensitive. How about if we did rubidium? We'd have to do a bunch of stuff for rubidium, right? We'd have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d, 1, 2, 3, 4, 5, 6, 4d6, right? Awesome. All right. So again, label your periodic table. And you can read exactly from your periodic table. So it really is kind of cool. All right. Noble gas abbreviations. Noble gases are in group 18, or the far right-hand part of the periodic table. And they'll include helium, neon, argon, krypton, xenon, radon, and okay. So you are going to pick the closest noble gas to the element that comes before. So in your notes, highlight that noble gas has to come before the element, okay? So potassium, if you take a look at potassium, potassium has an atomic number, or it has 19 electrons, and so the noble gas that comes before potassium is argon. So we will put that in brackets, and what that is saying then is that, hey, up to argon, the electron configuration of potassium is exactly the same. And then we have another electron to place, so it would be 4s1. Okay? Magnesium. We look at magnesium. It has 12 electrons. The noble gas that comes before it in the periodic table is neon, and then there are two additional electrons, 3s2. So neon, 3s2. Berkelium. Okay, berkelium is way down there at 97, and so 97, we have to remember, goes in that bottom row of the periodic table, and so the noble gas that comes before it is radon, and then we have 7s2, and then 5f, 1, 2, 3, 4, 5, 6, 7, 8, 9, 5f9, 7s2, 5f9, which is a whole lot better than writing 1s2, 2s2, 3, the whole way up to 5f9. So the noble gas abbreviations. And in your homework sheet on, let's see, page number 4, the top of page number 4, you have 1, 2, 3, 4, 5, you have 10 elements that you're going to do the shortcut notation. I can talk today. The shortcut notation for. There we go. Okay. Now, we talked a little bit on Monday and Tuesday, but electron configuration for ions. Remember, elements can lose or gain electrons to obtain the same number of electrons as a noble gas. If two atoms have the same number of electrons, they are said to be isoelectronic. So make sure you underline or highlight that term. Isoelectronic means they have the same electron configuration. And you're like, well, how can that happen? One of them will have to be an ion. So one would be the element, the other would be the ion. For example, the oxygen 2-, and that one is actually in your problem sheet, right? Oxygen 2-. Oxygen normally has, 8 electrons, but it will have 2 more because the oxide ion has a -2 charge. There are 2 additional electrons, and hey, that looks an awful lot like the electron configuration for neon. So the oxygen ion, or the oxide ion, is isoelectronic with neon. Okay, so O2- is isoelectronic with neon. And although they have the same electron configuration, they are not identical, especially from a chemical reactivity point of view. So that's an important thing to kind of keep in mind. All right, so write the electron configurations for the following ions. Okay, a rubidium +1. So let's find rubidium on the periodic table. Rubidium is a 37 electrons, but it has lost an electron. And so it will actually have the electron configuration of krypton. And so the rubidium ion will be isoelectronic with krypton. Give the electron configuration, given the electron configuration and charge, give the ion. All right, so this is 1s2, 2s2, 2p6 with a +2 charge. So I'm going to go to 2p6 and know that that is the electron configuration for neon. But this is an ion that has done what? If it's a +2 charge, it has lost 2 electrons. So this must be magnesium, because if you had magnesium with 12 electrons and it lost 2 to have a +2 charge, then it would have this kind of electron configuration. So it's the magnesium 2+ ion. All right, how about this one? We have 3p6. So let's see, 3p6 is going to be the electron configuration for argon, but this is something that has gained 3 electrons, so it has a -3 charge. So we would have 15. If we had something with 15 electrons normally that gains 3 electrons, then that would be the phosphorus -3 ion. Okay? Valence electrons. So the valence electrons are going to be our electrons that are located in the outermost energy level. They are responsible for the chemical reactivity of that element. So to count the number of valence electrons from the electron configuration, look at the highest numbered energy level in the entire configuration. And then you'll basically add those electrons together. So how many valence electrons are in each of the following configurations? You ready? Here's potassium. Potassium has 19 electrons. And if you look at the electron configuration of potassium, our highest energy level is 4. And so there's 1 electron. So potassium has 1 valence electron. The 4th energy level is the highest, so it's the valence shell, and there's 1 electron, 1 valence electron. How about cobalt? Here's the electron configuration for cobalt. Now be careful. Notice this ends in 3d7, which would tell you where to locate it on the periodic table. But this 4 here is actually the highest energy level. And so how many valence electrons does cobalt have? You should see that it has 2 valence electrons. How about neon? how many valence electrons does neon have? Well, here's our electron configuration for neon, and we look at this 2. So there are 2 s electrons and 6 p electrons. So it's the total number of electrons in that energy level, and so neon will have 8 valence electrons, 2 plus the 6. That pretty much concludes our notes for today. And so remember, the homework that I am going to check when you come to class is pages 1, 2, 3, and the very top of 4. I will make a separate video in which I go through Part D, the Part D chart about gaining and losing electrons. So look for that as well. But keep up the good work, guys.